y-intercept if the equation is written in slope-intercept form. So when I take a look and I'm looking at y equals mx plus b, in question 1 for all 3 forms of the equation, and in number 2 for all 3 forms, and in number 6 for all 3 forms, all of those were in slope-intercept form. And the key thing you need to be thinking is when an equation is in slope-intercept form is what is your start point? That is always 0b. And then you need to think, what's my slope or my movement, rise over run. The next thing you have to think about is where these dividing lines are. And my hint is maybe you draw all 3 lines and then you erase so that they fit in each of these areas. The other thing I would suggest doing is maybe putting that face so that you remember that a positive slope goes up and a negative slope goes down, and a 0 slope is going to be a horizontal line. Where is this important? When I look at number 1, the first thing I'm going to have equation 1, 2, and 3. In equation 1, my start point is 0, 6. My slope is 2 over 1, and it goes up. The second equation in number 1 has a start point of 0, negative 2. How do I know it that quickly? Because that's my y-intercept. My slope in this one happens to be a negative 2 over 1. I know that that line has to go down. The last equation of those 3 in number 1 has the same start point as number 2. It's 0, negative 2. So if I start at 0, negative 2, my slope in the last one has a slope of 3 over 1, and it's really steep. Okay? So I'm going to go to each one, and I'm going to start 0, 6. Oh, 0, 6. 1, 2, 3, 4, 5, 6. 0, 6. I'm going to end up erasing this point because it's not on the right side of the fence. This person lives way over here in this neighborhood. That's the only place they live. They're not going to be in the other person's yard or neighbor, right? They're going to stay within their neighborhood. So I start here at 0, 6, and the slope was 2 over 1. So I know, oh, this is what 2 over 1 looks like, going like this. But I can't have this part of my line. So I can't go in this neighborhood. This is the third neighborhood. I can't be in this one, down 2 over 1, down 2 over 1. So where is this line going to be? It's going to be right here over. And I would end up erasing this part of my line, okay? I erase that point that's right up here. I'm not going to have that point on my line anymore, right, on my y-axis. So it's a closed circle here with an arrow. The second one is telling me, as I look at it, to go to 0, negative 2. Some of you are going to 0, negative 2 on the x-axis. If you're not sure how to plot the x and y-intercept, we got to make sure you're understanding that. On the back of your workbook notes, please turn to the back and look at all those videos and things that you could do. And I would tell you anytime, you can do a search of just plotting piecewise functions and go to Khan Academy or go to Google or go to YouTube and put help plotting, help graphing piecewise functions, and you're going to see a ton of stuff that would help you. So in this case, we started 0, negative 2, and our slope is negative. Oh, that means my line had to go down, so I have to go down 2 and over 1. Am I in the right neighborhood? Is it in this last neighborhood for equation 2? No, equation 2 is only in this little tiny neighborhood right here, right? So I can't go down 2 and over 1. I'm going to go up 2 and back 1, and up 2 and back 1, and it is only this little part right here. Okay? That's the only part that this graph is in, only between negative 2 and 0. And then the last one starts again at negative 2, so I'm starting down at negative 2, which we already had that as our y-intercept. It's already a closed circle right here at 0. And now I am going to go up 3 and over 1, up 3 and over 1. And then I'm going to continue that. So I would say if you're having problems with number 5 for the first equation, what's a little different is it is in point slope form. Point slope form is when you have the m x minus x1 plus y1, kind of like our absolute value. What you're going to look at for equation 1 up here is your start is not going to be at 0, negative 3. You need to know that the start is at negative 1 minus x, negative 3. And the slope in this one is m is equal to, was it 3/2? Is positive. And the second graph, number 2, the start point is at 0, -1, and the slope is 0, so it's a horizontal line. And if you're stuck with that part of it, make sure that you're seeing me or we get some help. So number 7, let's just take a look at number 7. Number 7, the first thing in number 7, I would say, what is your start point? Start point in number 7 is going to be, or our vertex is at -1, 2 is my vertex. Is my V going up or down in number 7? Number 7, would you say up or down as I look at it? Anyone? Should be going up, right? It was positive, right? So I'm going to go to -1, 2. It's going up. So I know that I have a V shape going up. And now I'm going to use my slope, and the slope was 1/3. So I'm going to go up 1 and over 3. So up 1 over 3, up 1. If you didn't have yours done, you should make sure you have yours done. For the ones that I just did up here, we're going to go up 1 and go back 3. It's a pretty wide, as I was looking at that. Okay? So, making sure as you look at those, if you have, so in your textbook, this is kind of a different section. It's back in 4.7, chapter 4 is what we did kind of on that last test. And we are looking at what a sequence is. So we're going to look at our vocabulary first as we are taking a look at this. All of these I can statements, we're going to be working those through and looking at those, so make sure. But a sequence is just an ordered list of numbers, often in a pattern. I think if you think back to some of your early tests in elementary school, you saw a list of numbers like I have below. Each number is called a term or an element. So just different vocabulary that we're using. When we talk about a sequence is, when we are looking at that, a function. And the domain are the counting numbers, or natural. So we did on our graphs, we had all real numbers when we were looking at it. This is only counting numbers, which means you won't have a fraction or decimal for the number of terms. Okay? So when we are taking a look at this one, I gave you some examples, right? What's happening in that first one? It looks like we're doing what all the time?
Adding by 2.
Adding 2, right? The next one looks like we are adding
3.
Those are both arithmetic sequences. The last one's a special one, right? Yeah. Oh, we're not adding 3, are we? We are doing what by 3?
Doubling everything.
Where each time we are multiplying by 2, right? And this last one's special. It's called the Fibonacci sequence, and that one's a little different. What happens is that to get the term, the next term, you add the 2 before it. So 0 plus 1 gives you 1, 1 plus 1 gives you 2, 2 plus 1 gives you 3, 2 plus 3 is 5, 5. You'll see that on different posters. I have one in the back of the room. There's a couple other ones around there, but nature, numbers of Fibonacci numbers in nature, and looking at those are kind of special numbers that we take a look at, and they have patterns that come up all the time. So we are going to be looking mostly at what's called our arithmetic sequences. So on that next part down, I want you to look at these rectangular numbers. So if I was looking at the pattern, the first one, if I'm looking at, the first number that I have is 2, right? So this is my pattern. This is the number. How many dots are in that first rectangular number? 2. The second one, 6, because it's a 2 by 3. Then you have a 3 by 4, it's 12. We have a 4 by 5, which gives us 20. So the question says, what is our pattern? What does it look like is happening each time? So if we are looking at this, we want to write down 1 times 2, 2 times 3, 3 times 4, 4 times 5. Okay? So when we are writing that pattern, right? 1 times 2, 2 times 3, 3 times 4, as we are looking at that, we start with 2, and notice, then we add 4, then we add 6, then we add 8. So if I was looking over here, I start at 2. This is an addition of 4. Here we added 6. 6, right? We added 8. So, can I figure out the next number? What do you think I'm going to add? 10 should give me 30, which it's supposed to be a what? This was a 4 times 5. This one should be 5 times 6. This one should be what? 6 times 7. Please fill in your table. Do you think you can fill that table in right now? Yes or no?
Yes.
Yes, definitely yes. Each input, one output. What's our domain? We just said the domain is only going to be what kind of numbers. It's not going to be all reals. It's not going to have any negatives. It's going to be our counting numbers or natural. We don't have 0 term, right? We start with our first term is 1. Our second term is 2. So when we are looking at this, this is my terms right here, right? This was this, in this case, the rectangle 1, right? So my terms, in this case, we called it our rectangles, okay? But usually refer to it as the terms. So it says, well, how many dots are needed to get to our 10th figure? As we are taking a look at that, to get to our 10th one, what would we think? It's going to be 10 times 11, which is 110, right? Does that make sense to everyone? Because if I would have gone one more to 10, I would have had 10 times 11. So it says how many dots are needed. Write an expression to model this pattern. So when we are trying to model this pattern, I want you to take a look and think of this as being our n. Okay? So this is n. And here it was n, or 1, times 2. If n is equal to 1, what is 2 equal to? N plus 1. So when n equaled 9, right? We just said here, in this one, when n was equal to 10, what did we do to get 110? We took 10 times 11. That means we took n times, what is 11 compared to 10? It's 1 more, n plus 1. So here's how we're going to write this notation. We are going to say a to the n. Different notation. We haven't had subscripts before. We have a little when we did slope, but we haven't had this before, so this is new for all of you. A to the n is equal to the nth term plus 1 more than that. So this is like the 9, and this is 10. This is 7, this is 8, right? n plus 1. So it says, well, how are we going to find the 100th term? So here's what we are going to do. We are going to write this, but instead we're going to put a to the 100 is equal to, what should I replace n with? 100. Why? Because I just put 100 here, right? So 100 is in the same place as n, times
100 plus
101. So by all means, multiply your calculator, and let's figure out what that is. This, just remember that as you are looking, some of this seems a little odd, or maybe you're struggling with it at first. You got to just work a little harder at it. It's got to come in and get those questions clarified. So, sequence notation versus function notation. So, because we use a special notation to show sequences. It is similar to our function notation. Remember before you hadn't really seen f of x. You had only usually seen y equals. So function notation was written this way. This is going to be our sequence notation. So when we look at sequence notation, it's going to give something like this. It says the 10th triangular number is 55. Therefore, we say the 10th term in the sequence is 55. They write it this way. T of 10. Because it's the 10th number in the sequence and it equals 55. We read it as T sub 10 equals 55. So this would be term 1 is 1. Term 2 was 3. Term 3 is 6, okay? If I was making this list, this is what it would have looked like. It would have looked like 1, 3, 6, 10, right? That's what the sequence would look like if it was just written out. It would look like this. This is how we tell what the terms are, okay? So that little subscript is called the index. It just tells us the number of the term. Sequences are functions. Their domain, no more real numbers, are natural. So when you think about those natural numbers, that's like 1, 2, 3. We represent them using function notation or sequence notation. So when we say it's a function, we usually use f of x. When we say that when we are looking at the sequence notation, a lot of times they use t. They might use a, they might use f sometimes for this. This is because they were talking about triangular numbers. So it's t sub n is equal to, how do you find area of a triangle? Base times height divided by 2, so those triangular numbers, that's how that, and they just looked at a pattern of numbers to come up with that, okay? You don't have to come up with those equations yet. We're going to be using them. So this is called, on the bottom of that next page, an explicit formula. The formula describes the term of the sequence in terms of its position to the sequence. This is an explicit formula for a sequence because we can calculate the nth term directly, or call it explicitly in mathematics, by substituting in a value for n. I named the sequence t so that I could use any other letter if I wanted to. So if you don't want to use t, you want to use a, you want to use k, you want to use c, it doesn't matter. It's just a letter or a variable we're substituting in. So this one says, well, what is our 20th term? So again, we want to go up to the formula, and you're going to replace 20. Any place where n is, you're going to replace 20. So we would have 20 times 20 plus 1 divided by 2. So I have 20 times 21 divided by 2. Now I'm looking at this, and before even using my calculator, I'm thinking, oh, well, 2 goes into 20. 2 goes in here once and in here 10 times. And 21 times 10 gives us 210. So if I was looking at this problem, I might be looking at it and go, oh, this was not that hard to do. And I would write my final answer of t sub 20 is equal to 210. Okay? So 3 squared is 9, right? So fill yours in as you are taking a look at this. You should have these memorized. If you don't, so we're looking at 16, right? We're looking at 25, okay? And notice that I have below this, notice that as you're looking at this, when you get down to the nth term, what was it equal to? N to the second power. So we are going to first write our equation. T to the n is equal to n squared. That's my sequence notation. I'm going to find t to the 250. Probably want your calculators, right? We're going to take 250 and square it. So term 250, if I wanted to go in this sequence, 25 squared is 625, right? It's come out to be 662,500. Okay, and again, putting it in your calculator if you're not sure as you are taking it. You're going to be asked on our standards for this unit, you have to be able to write sequences recursively and explicitly. That is one of our standards that you have to be able to do. We're going to be working on this for lesson 9, 10, 11, and then I think 12 is where we start doing review, getting ready for our test. Okay? So a recursive formula, again, piecewise, right? So 2 pieces, just like we've been looking at the last couple of days where we have that fence where we're thinking of it that way. You have a first term, and then the second part, B, is always going to be a rule. Okay? That's going to be like how you're doing it to get the next term that was previous. So if we are taking a look at ours, it says a to the 1, and we're always going to put whatever was the first number in your sequence. So like in this case, down here, they give the example. The first one is actually 40. It's the very first term. Then it says, for the second part, a to the n, you're just trying to fill in how do you get the next number. So if we are looking at this, this is going to be an expression that shows us what to do to the previous number. Are you adding to? Are you subtracting? Are you dividing to get the next term? The previous term, okay? So if n is the first term, the one before it, previous, is going to be n minus 1. That's all this n minus 1 means down here, this subscript. It just means previous. All this means is the word, the previous term. So I'll have people go, I don't know what n minus 1 is equal to. It just means previous, the one before whatever term this is, whatever the nth term is. It's the one prior to it. So here it says the first term is 40. The pattern is to take the previous term and divide it by 2, right? 40 divided by 2, 20 divided by 2, we keep dividing by 2. So how do they show this? This means previous. This whole thing right here means previous term divided by 2, okay? So top of the next page, this is a lot of vocabulary part. The top of the next page, it says, oh, you are going to repay a $200 loan, and you're going to make a payment of $20 each month. You're going to receive a statement telling you how much you owe. So the bank is going to say, okay, how much do you owe? So you had $200. After your first payment, how much do you have left to pay? After your first payment, T sub 1, we have 180. So you need to start with T sub 1 equaling 180. Okay? What's going to be your second term? They ask us to list the first 6 months. So T sub 2 is going to be 160. Subtract 20 again, right? 140 and then 120. And does that make sense? List all 6 of them. How do we want to list them? We want to list them just as I did up here. T sub 1, T sub 2, T sub 3 equals T sub 5 is 100, T sub 6 is 80. So now it says write a recursive formula. So recursive, you have to tell me what the first term was. What's T sub 1? It's equal to, we are looking at it, T sub 1 is, T sub 1 equals 180. Usually they put these brackets around it. Why? To show that there's 2 pieces to it, right? Then we're going to say T sub n. So how do I get the next term? I take, if we are looking at it, the previous one, t to the n minus 1, that just means previous. This whole thing right here means previous, and then I'm subtracting 20. But we also always have to tell for what, right? This, if we think of the piece, was for t equals, or the n equals 1. This was when the subscript was equal to 1. This is for n greater than 1. Because this, if this is 1, that's the 0 term, right? So n has to be bigger than 1. So it's like 2 minus 1, or 3 minus 1, or 4 minus 1. So we always want to put those pieces to tell me like where the fence is from yesterday's notes when we were talking about that. So they ask us to write a recursive formula for this one. -2, 3, 8, 13, 18. You want to start with what is, and as you are looking at this, term 1. So T sub 1 equals, and then T sub n equals. T sub 1, as I look at it, is -2. What's happening to -2 to get 3, 3 to get 8, 8 to get 13? We are always adding 5. So my rule is going to be to get, so this is 4, we are looking at it, n equals 1. This rule is going to be take the previous one, n minus 1, that just means previous, and add 5. And then we're going to say for n greater than 1. How can I check that this is working? So, like solving equations, if I find T sub 2 using this formula, that means I take the previous. What was my previous term? The previous was -2. And if I add 5, oh great, I got 3. And if I wanted to find T sub 4, I'd look at the third term, right? That's the previous. The previous is the third. Oh, the third term was 8. And if I take 8 and I add 5, oh, great, I got the fourth term. This is the fourth one. This is what I said it was supposed to be. The formula worked, right? So you can always plug in and check that it works. And if it doesn't, then maybe you should have had a different formula, or you need to just check something as you are looking at that, okay? So, tonight's homework, if you would please turn in your workbook. That number, minusing 4, and I get 6 minus 4, so it's 2. So right now I have -1, I have 2, and they want you to list 4 in each one. When you square it, remember, order of operations, you have to square before you add. Okay. I want you to look down at some of these later ones. It says find the value of the equation in the sequence. Find p sub 4. What are you replacing all the n's with? With 4. So every place where there is an n, you're going to put in 4. And then you're just going to do the math. So you're going to leave it with 4 times 4 plus 1. 4 plus 2. So 4 times 5 times 6 divided by 6, and you're going to tell me what it's equal to, okay? So, they give you, in this one, they kind of give you a formula, and they're asking after 8 weeks, right? So that just means the n is going to be replaced with, what do you think? N should probably be replaced with how many weeks we're looking at? 8, right? And it says, well, when should he stop dieting to wrestle at 103? Meaning we don't want him a lot under 103, right? Like we don't want him down to 98 pounds if he's wrestling 103. We want him to be as close as he can. So here's how I want you to start this one. Here's the formula with the weight, right? So please put W sub n equals, the person was losing 1.5 pounds a week, right? Plus 110 is where they started currently. What you are going to do differently in this problem than what you did up here. Here you are looking at n equals 8. Here you're putting this weight is 103. Equals negative 1.5 n plus 110. And this is solving basic equations. You did this last year. You did it at the beginning of the year. Solve for n. That's all you're doing, right? I need to know what is n equal to. So you're going to subtract, do your division, okay? As you take a look at that next page, make sure, as you take a look at that next page, you are asked to find the first terms. You are asked using, so these are going to be, right, that different type of formula that we're looking at. We're looking at recursive formulas. Here, you're looking at these. Use your answers and check as you're doing these. I had a couple people that were not checking their answers on all those absolute values, and they did lines for every single one, and they all should have been V's, right? So before you do more than 1 or 2 problems, turn and check those answers in the back. I will be in here to help you if you have questions. I'll be here again tomorrow morning. Like I said, advisory